See here, in the previous class, we discussed about the fundamental particles. What are the fundamental particles? They are electrons, protons, and neutrons. Okay. They are electrons, protons, and neutrons. Now, electrons are negative charge particle. The charge of electron is minus 1.602 into 10 to the power of minus 19 coulombs. Mass of the electron is 9.11 into 10 to the power of minus 31 kg. And if you're comparing the charge of electron with the charge of mass of the electron with the mass of the hydrogen atom, it is mass of electron is 1 by 1837 the mass of the hydrogen atom or proton, because it is very, very small. Next is proton. So discovered by Rutherford, and charge of proton is plus 1.602 into 10 to the power of minus 19 coulombs, and mass of the electron is 1.67 into 10 to the power of minus 27 kg. Okay, and neutron is there is zero charge, and mass of the neutron is 1.67 times of 10 to the power of minus 27 kg. Now, so there are now in this lesson actually there is one more situation, that is E by M ratio, which is very, very important. That is said to be specific charge of electron, that is 1.76 into 10 to the power of minus, that is 11 coulomb per kg. So minus 11 coulomb per kg. So this is also important value. Now, there are different ways in which the electron can be emitted. What are the ways? One is thermionic emission. It is not here. The thermionic emission. First is thermionic emission, cathode ray emission. Third one is photoelectric emission. Thermionic emission means when you heat the filament, it gives out electrons. Okay, apply very high potential difference across the filament. Then what happens? It starts giving out electrons. That is first way. The second way is what? If you take a like this tube and fill it completely with gas or something like zero group element, or if you remove that, just fill it completely with vacuum also. And when you apply the potential difference, electron starts going from cathode to anode. This is said to be cathode rays. Okay, this is also a form of electron. Best example is a tube light. Okay. Third example, the third way is photoelectric effect. When light incidents on a metallic surface, electron is ejected out. This is said to be the third, that is photoelectric effect. This was first demonstrated by whom? Hertz. Okay, what did Hertz say? Here, when light incidents onto this metallic surface, electron is ejected out. Okay, so that is said to be Hertz photoelectric effect. So the same thing here, what he did when light was made to incident on this one, and this is completely vacuum evacuated chamber. Vacuum evacuated chamber. Once again, just see here in Hertz observation, what he said, he has taken vacuum evacuated chamber. Means what? There is a tube tube in which there are two plates, positive plate and negative plate, means connected to the potential difference. That is not shown here. And there is no gas in it. When you apply the potential difference, what happens? The electrons will start from C and go towards A. C is said to be cathode, which is known as a negative plate. A is known as anode, which is known as a positive plate. This you did in chemistry also, the same thing. Now, next is what Halbach and Leonard's observation. According to him, same thing. What they said, when ultraviolet rays are incident onto this plate, then what happens? Electrons are ejected, and it is taken by the anode. So you can see the motion of the electron when you see the deflection in the ammeter or milliammeter or microammeter. Okay. Now, so what I was trying to explain here is about how the light is coming out from the tube light or from the bulb. What happens when when you give energy, electron comes out, or it goes to the higher energy level. Electron will go to the higher energy level. So once I'll just quickly explain this one. See here what is happening here. Like suppose this is the nucleus, and this is the electron. Okay, suppose the electron will jump from lower energy level to higher energy level. So what happens? It will absorb the energy. It will jump from higher to lower to higher. Then when it is coming down, it releases energy in the form of light. This light we are able to see from the tube light or from the bulb. Next is photosensitive material. What are the photosensitive material? The material which is used for this particular purpose, photoelectric effect purpose, is photosensitive material. They are lithium, first group elements: lithium, sodium, potassium, rubidium, cesium, and francium. Next one is photoelectron. The electron which is emitted by this is known as photoelectron, and the effect is known as photoelectric effect. When light incidents on the surface, then electron is ejected out. Okay. So here H nu, and this is the electron, and this is the pi. Pi, what is pi? Pi is the work function. What is work function? The minimum energy required to bring an electron to the surface of the metal. So the electron is somewhere inside, and when you give energy to this particular surface, then the electron will come to the surface. To the atom, the electron will come to the surface. That energy is known as work function. Now, what is threshold frequency? This experiment is done by different color lights. Maybe it can be done by infrared light or infrared radiations or visible rays, or it can also be done by ultraviolet. But because infrared and ultraviolet, they are in, they are not in the visible region. We cannot see that one. So for that reason, what we are doing is we are taking visible light, which is easy to understand. So if you look at visual colors, like, violet has high frequency, red has low frequency. Now I started from low frequency. When red light is incident on this, maybe electron is not ejected out. When I incident orange color light, electron is not ejected out. When I incident yellow color light, electron is not ejected out. So, but what happened at a particular frequency, maybe at green color light, electrons started coming out. That particular frequency is known as threshold frequency. The minimum frequency of incident radiation for which electron is ejected out, that is known as threshold frequency. Now, we'll quickly move towards Albert Einstein's photoelectric effect. What exactly he explained? See, Albert Einstein in 1905, okay. So Albert Einstein in 1905, he published around three research papers. He's not the date of birth actually. 1905, he published three research papers. And those three research papers became famous throughout the world. And in 1906, I will tell you what are those papers. He published one more paper. Okay. He published one more paper. Let us see what exactly he published. Okay. Just 1 second. Okay. See once again here. Albert Einstein 1905, he published three papers, okay, which became very famous throughout the world. One is photoelectric effect, second is E is equal to mc squared, third is Brownian motion. On photoelectric, and in 1906, he published special theory of relativity. And he became very famous for this, but not later on, after getting the Nobel Prize. So he did his PhD on photoelectric effect, and he got the Nobel Prize also on the same concept. What is actually the special theory of relativity? Suppose when any particle is traveling with a speed comparable to the speed of light, means what? Maybe 0.5 times the speed of light, maybe 0.25 the speed of light, maybe 0.9 the speed of light, something like this. So at that time, you cannot apply mechanics. You cannot apply mechanics. So for that, you have to go for some other system, because our normal acceleration, velocity, and all will not work out at that time, because the mass will not remain constant for that situation. Generally, if any car is moving with a speed of 120, does the mass of the car change? If a car is moving or 130 or 140, does it change?
No,
it won't change, right? But when a particle is moving comparable to the speed of light, the mass of the particle will not remain same. So that's why we have mass, time dilation, mass contraction, length contraction, something. That concept has come into picture. Okay, he gave this concept. Actually, he was supposed to get the Nobel Prize for this, because at that time, no one could understand this concept actually. No one could understand the concept of special theory of relativity. But later on, we have three big laboratories. One is in Russia, one is in Europe, and one is in US. These are the three big laboratories which is underground, around 30 kilometer deep, and it is 25 kilometer in perimeter. That much big laboratory is there, which is like, have you seen this movie? Angels and Demons.
no, sir. I don't watch movies.
Yeah, no. It's like a English. It is like not like it's like a English. It's like about the electron, the scientific particle, how the electrons, or when the atom goes with so and so speed. It's about that. Okay. So there you can see the electron, the particle goes with very high speed, equal to the comparable to the speed of light. Then what happens when any particle goes with the speed of light? It hits the atom, and the nucleus will burst, and so many new particles will come out. And we are studying about those particles. Okay, so that is actually said to be high energy physics laboratories. Okay, leave it. That is not in the syllabus. So just I would like to know why it has gone more. Why this fellow got more fame in physics field because of this. Understood?
Yes, sir.
Yeah, okay. Now we will go to the next concept. What is that? So Einstein's photoelectric, that is photoelectric effect. Okay, which is explained by Albert Einstein. Now, 1 second. Okay. Now see here.
Yes, sir.
Now experimental study of photoelectric effect. Okay, we'll do this now. So we have, that is experimental study of photoelectric effect. Experimental study of photoelectric effect. Okay. Now here, so this is the thing. So this is a vacuum evacuated chamber, but here see, this is vacuum evacuated chamber, and here it is mica window. Okay, a quartz window. Light is coming from the source here. Okay, and it incidents on this one. So this window is said to be quartz window. Yeah, quartz. It is known as quartz window. Okay. Now here there is a commutator.
Okay.
So here this is a microammeter. And there is a voltmeter. At last there is a, okay, I cannot draw that now. So what I have to do now? And reduce this level. Okay.
Yes, sir.
Now so here Okay, so here it is battery. Okay, this is a cell. Now here what happens here? This is C, cathode, and this is anode. Okay, cathode and anode. Okay, you can get it down.
Yes.
Now there is a cathode and anode. When light incidents from the this is photosensitive surface. Photosensitive plate. Okay, this is photosensitive plate, and this is the next one is evacuated glass tube. This one, evacuated glass tube. Evacuated glass tube. And these are the electrons. Electrons start coming out. These are the electrons. Electrons start coming out in this way. And this is said to be commutator. This is said to be commutator. And here we have the other section. So this is the source. This is the source. See once again from the beginning. When light incidents here. Once again. Charge this.
Yes.
Now, see here. This is a source. When light travels to the quartz window, it hits on the incidents on the cathode plate, and electrons are ejected also. This will go towards the anode. Okay. Now, here there is a commutator. It means a two-way switch. It's like a two-way switch. Now, what happens when this is a photosensitive surface? It hits on that one, but we have to provide some potential difference. Otherwise, where will the electron go? That is important. So we have provided a potential difference, and this is a rheostat where we can increase or decrease the voltage. How much voltage you want? And here voltmeter is there, ammeter is there. Ammeter is used to find how current is flowing, how much current is flowing through the circuit, and voltmeter to check how much is the voltage. So now this is about the experiment. Now there are 4 studies here, 4 different graphs. Very, very important. This is actually crux of the lesson. Okay, this is actually the crux of the lesson. The first one is first copy this one, then we will quickly move to the explanation. Okay.
Yes, sir.